Okay, good morning. This is Tan Nguyen with ASPEN. Welcome to ASPEN webinar. With me today is Sherman Chan, and there was other panelists that I will introduce shortly. Okay, so I think we are ready to start. Let's go. Okay. Okay, so what we have today is the ASPEN webinar where we talk about the what's new in ASPEN OneLiner version 15, which we had sent out to user in July. The webinar will be lasting for 90 minutes. That, in other words, we'll have 90 minutes from now to talk about it. And what will be happening is we'll have a short introduction and some logistics items. And we'll then go straight to Q&A because we, as in the invitation mentioned, we already sent you the list of what is new in the program, and hopefully you have been able to go through that. And I'm afraid that you have a lot of questions. Well, so we are here and we have 90 minutes to talk about it. Okay. So the panelists are, like I said, there's Sherman Chan from ASPEN, myself, Tan Nguyen, and also there's Su Zhang, another ASPEN developer. So we know more or less something about OneLiner version 15. And also, as you've seen in the what's new, there's an additional feature in OneLiner version 15 that let other developer to write additional application that works with ASPEN, and Quanta Technology had already had a head start, and they were able to make a couple of very useful application. And Quan Ha Wen from Quanta is here today, and if you have questions about those applications, he will be the person to talk to. And how do we talk to each other today? Here's on the screen is a picture of the control panel of a GoToWebinar. And those arrow pointing out, yeah, that's how you can ask questions. I'm sure you know more about GoToWebinar than ourselves because it's first time we are using this platform. But anyway, as far as we know, you can either type the questions in that box, or if you push that raise hand, one of us will notice it, and then we'll tell you such and such, you have a question, you can unmute your microphone and talk, and hopefully the microphone will work. But I think the preferred way to ask question is just type it in so that there's no ambiguity about what you want to say, because the microphone may work or may not work. Okay, and if you prefer, you can also write a quick email and send it to support@aspening.com. Sue and I is monitoring it, so we'll see it. And the last resort is you can also call the ASPEN support line, and then pick extension 1 and talk to Sue, and he can write out your questions and read it back. Okay. And so version 15, like I said, OneLiner has been we must say 4 years in the making, and we still haven't finished it. Sorry, but still it's good enough for you. So we had decided to send it out so that we continue working on additional detail. And it was sent out last month. Some of you already got a hold of it and tried that. Some I think the IT is still sleeping on it. So, but it's there. And also the second item is we sent it out, and then people reported, or we found minor problems with it, and the updates are available. So if you downloaded the setup from the beginning of July, before you install it today, you want to write to ASPEN and get the update setup, because that will save you a lot of grief, because we've seen some annoying thing and we already fixed them. So better just call ASPEN and get the latest. And I also want to announce that we have designed and will be provide a special ASPEN training course just for the new feature in this version. It will be web-based and it will run for 1 week. You will have the full access on demand to the video and material. Everything's about the new feature in this version. And to register and enroll, go to that event page on the ASPEN website. All the details are there, including the syllabus and the registration. Now, what's the good news is if you have taken one of the regular ASPEN online class since last year, web-based on the same platform, we have provided like 3 regular ASPEN training since last year. If you had taken one of those, your enrollment to this class will be free. In fact, you will automatically be enrolled. So write out the date, mark out your calendar if you are one of those people who took in, so that you can take part in this training course. Okay. All right. So this is showtime. Questions? Do we have any? Okay, so I guess that then if you don't have, when you're still thinking about that, then let me ask you this. Can you just click on yes or no and tell us whether you have seen this? Okay, we have 50-50, half of you have seen that, and about half have not. Okay, so in the download handouts for this webinar, there's a PDF file of that what's new. You can also open that what's new in from the ASPEN website homepage, and if you haven't seen that, and this is it's not too long, you can also go through that right now, and you can ask questions about that. Okay, so I think that's the cool. Okay, so I guess some of you already sent some question earlier in email, and I think that question went to Sherman. So I'll make Sherman a presenter now, and he will be able to talk about that. Okay, hold on. Sherman, you are a presenter now, and if you want to talk, just unmute your microphone and say something.
Mm-hmm. Hello, this is Sherman Chan. I thought I'd just maximize my window, but in fact it disappeared altogether. And let me start my OneLiner program again. Okay, so it is, what does that do?
We don't see your OneLiner yet. It was there, but it's gone.
Okay.
Okay, got it.
Yeah, right here. Okay. I'm not going to try to use that maximize window button. Okay, here's this, what I'm going to talk about. I received an email message from one of you that has to do with computer interface device, or I call it CIR from now on. And I think a lot of you may have questions about that. So I'm going to just talk about that in general. And also maybe in the course of my talking, I also answer some of the questions that that person wrote to me. So here, you see that I have a little device with a little 4 in it, and that's a CIR. Now, this CIR is connected to this power system, a very, very small power system, but this could be an equivalent. So this, you can see on the right-hand side, it says system equivalent. So this could be the rest of your system. Now, I want to point out a couple of things, is how this device is connected to the system. You notice the first thing it does is it's connected to a a Y-delta transformer. But if you look carefully, this Y-delta transformer has the Y on the generator side and delta on the collection network side. Now, this may look strange to you for those who have work regularly with synchronous machines, because for those machines, in order to block the third harmonics from coming into the power network, the delta is always on the generator side. But when you have CIRs or type 4 wind plants for that matter, the Y is on the generator side, okay, and not the delta. So that be sure you make note of that. Now this part over here, in this particular example, was supposed to represent the collection network. Now I don't think that's really necessary, and I would if I were doing this, I would just omit this altogether, because what happened is that oftentimes you have 100 of these CIR devices, and I will ask you, if at all possible, to aggregate them into one, as much if that's at all possible. So there's no point in representing this collection system, which is usually at about 33 or 34 kV. And then finally, before attaching to the power system, this goes through a delta Y transformer in some cases. Then you notice now that you have delta on this side of the, and you have delta on this side. So in this oftentimes presents a problem for single line to ground faults, because if any of those single line to ground faults happen here, the voltage would go sky high. So normally people would either provide a shunt over here, like a either a zigzag transformer, which is kind of expensive, or they would put a Y-delta transformer here with the Y connected to the 34 kV and the delta not connected, and that provides a shunt. And on this side, you can also avoid doing this shunt if you use the Y-delta transformer, okay, with the delta again connected to the generator side. So this is how important that you set this up. And now let me open the dialog box for this type 4 wind machine for you to look at real quickly in case you haven't seen one yet. Okay, so here's a picture of that of the first page of the dialog box for the converter interface resource, or CIR. Okay, now you notice that I asked you for the number of units because I want to make sure as much as possible that you aggregate these guys. So if you have 100 units, well, just type 100 in here. And then we'll ask you for the MVA rating of each unit, so you can put it here. And then if you want to represent the pre-4 megawatt generation of these units, that you enter over here. Now I will explain to you very shortly why you should put 0 at this position. Down over here in this box, asks you for the maximum current that this CIR will put out. And the most common numbers are somewhere between 1.2 to 2.5, with somewhere around that number. It's not, now they say, well, I have some spec sheets that says that it puts out 20 times the current. Well, then in that case, you need to look more carefully at the spec sheet to see when they're talking about. If they're only talking about the first quarter of a cycle, or even half a cycle, you don't want to use that number, because what you're looking at that time span is the transient response of the CIR. In other words, you put a fault in front of that, all of a sudden you get a very powerful transient of the energy discharged into the fault. So look for something that's at least about 1 cycle out, 1 to 2 cycle out. And generally, if you do that, you will see that the number would be somewhere between 1.2 to 2, or maybe even to 2.5. Most commonly, they're between 1 and 1.2 to 1.6. That's the number that I see most often in data sheets. Okay, I'm going to omit this part here and go to the advanced setting dialog box. This asks you about 2 different things. I know it's hard to read on some people's computers because the characters are kind of small. It says here, slope or positive sequence dynamic reactive current injection. This characteristics. And bottom of here says the same thing except for a negative sequence. Okay, now 99.9% of CIRs in the United States or in anywhere outside of Europe at this point have no negative sequence reactive current. So that's why this second dialog box is set to 0. Now, but I do expect that within a year to 2 years, there will be such animals here. So in that case, you need to deal with it. Now, what we have right now is that you do have to specify a positive number for the slope or positive dynamic reactive current injection. Now, what does this mean? You know, what does 2 mean here, for example? Let me give that as an example. A 2 means that when the voltage drops from 1 to, let's say, 0.7, so the difference between 0.7 and 1 is 0.3, okay? So then what this tells, this slope of 2, you multiply that 0.3 by 2, you get 0.6. So what it tells the CLR to do is to inject 0.6 per unit. And then let me say that again, 0.6 of the follow current as a reactive current into the network, okay? So that means that by the time the voltage drops to 0.5, it would inject the follow current in the form of a reactive current. What do I mean by reactive current? The current is purely a VAR. In this case, is purely a capacitive VAR being injected by the machine into the network. You say, well, what happened then at voltage below 0.4? Well, nothing. The program would nothing different. The value would still be 2. Now, at that point, it depends on the limit you set on how much current is being injected. And that's a kind of fine point I want to just skip at the moment and just keep on going. Now, at the bottom of this box is the range of voltages that you allow this device to work. Right now, it's between 0.01 and 1.2. Okay, that means if all the phase voltages are between this range, then the device will work. But when they go outside of this range, it will stop working. So this tells you that if you put a dead 3-phase fault in front of one of these machines, it's not going to work, because in that case, the phase voltage will be all below 0.01. Okay, so that points out that if you want to test these things, best to put some kind of 1 ohm or 2 ohms of resistance to the fault. Otherwise, you're not going to see any output at all. Okay, so let me go ahead with all that. So if you have questions, go ahead and type that in, and the Sue will tell us after a few minutes. So let me just go ahead and do a fault here and show you. So I specify a 3-phase fault first, and I would tell it to give me 2 ohms of resistance. So I press the simulate button, and you see some currents. Now, very, very likely, when you do it, you still don't see any currents. Well, why? Because under fault options, in order for this to work, you got to go here and check these boxes. The first box, the second box says simulate CIRs, and the third box says simulate type 3 wind plans. So make sure you check these. And also, in this version of OneLiner, in order to simulate any of these devices that represent either wind or solar or batteries, you have to use either from a linear network solution or from a power flow solution. Well, a lot of you don't have power flow license. So in that case, the only choice open to you will be from a linear network solution. Okay, so make sure you do this. Check this solution method and also mark these checkboxes. Okay, in this case, I do have it working already, and you can see that there are 82,000 amps coming out of this generator in positive sequence, and that's well, it is not as frightening as it looks, because by the time it gets to 34 kV, already goes down to about 1,300 amps. Okay,
Sherman?
Yes.
There's a question here that say, do you have to do the model at that low voltage level, or can you aggregate and just make it on the 34.5 kV? Will that work the same? That's a question from AEP.
Okay, I think the person asking the question is whether they really need to model this transformer. Okay, because this transformer brings you to from 575 volts to 34.5 kV, and my answer is definitely yes. And why? Because these machines are usually connected line to line, and without this Y winding here, and we know from experience, they just plain refuse to work. It's like having you connecting a synchronous machine to the system and you've forgotten to ground the neutral. Okay, not only you'll get fired, there could be something. It could also be a wheel fire going on in the generator house. So this is very essential to have this YDelta transformer. Okay. Now you don't have to.
Related question is that transformer. What if it's YY instead of YDelta? Would that work? That's another question from Charlie Handel.
Okay. If this is a YY instead of YDelta, I have not tried that, but you got to remember this represents the way that an individual machine is connected to the system, and they always done this way, and I haven't tried all possible configurations. So I strongly recommend that you do the way that these gadgets are connected in real life. And the only part I would omit is this very small line, that low impedance line that between this end and this end. And so since in this case I'm representing maybe 100 units this way, so you're not really wasting a lot of buses, because there's only one bus involved for these 100 units. Okay, so now let's take a look at what kind of current comes out of the generator at the collection system end. And I will use the Phasor Probe by holding down the control key and click twice over here. And this is the Phasor Probe in OneLiner. So I tell the probe to show me sequence voltages and sequence currents. And in addition, I click twice here. I guess I have to click miscellaneous. No. Okay, I click miscellaneous, and I tell the program to use the positive sequence voltage to rotate everything to 0 degrees. Okay, so you can see then the output of this generator is at 0 degrees, and the current is at -90 degrees. Okay, so this is a formula for injecting VARs into the power system. And this is always this. So this we consider this the p-axis. I mean the d-axis. And this is the q-axis. So the reactive current is always in this direction. Okay, 90 degrees behind the voltage. And so this is important. And let me see what else I can talk about. Okay, that person who wrote the email to me asked, how come when he does a two-line to ground fault, and then he does a two-line fault, I get a different output from the generator. Okay, the answer to that is that no matter what kind of fault you put here, let me put a single line to ground fault here for simplicity. Again, I put a couple ohms of resistance in here just in case, so that won't drive any of the phase voltages to zero. And now you see there's no zero sequence there. Well, why? Because this delta basically blocks any zero sequence output that could be coming out of the generator. Of course, from your network, there's zero sequence coming this way. And so the generator never generates any zero sequence current. And also I can look at negative sequence current. Now, if you concentrate on looking here, it also outputs zero negative sequence current. Okay, but this has to do with that slope of negative sequence slope being zero. And so currently, none of these CIRs in the North America, so far as I know, injects any negative sequence, because this injection of negative sequence is a mandate from the German grid system regulators only within the last year or so, maybe last year to 18 months or so. So the manufacturers are not making them quite yet, and maybe they are in Germany, but they certainly very few in here in the United States. And if they did that, then there will be a negative sequence injection, and that injection is always 90 degrees ahead of the zero sequence voltage phasor. Now, why is that important? Why is that negative sequence important? Well, because a lot of the relaying in North America are based on negative sequence. So if you don't have, you have things that inject zero negative sequence current, that could present a problem. So I know NERC has been very concerned about this and has held several meetings already with utilities and with relay manufacturers to discuss this. And so I expect that within the next few years, you will see negative sequence coming out of these machines. And as I mentioned, to make that happen, you have to go through this advanced thing and enter a positive number here. Okay, so that's the negative sequence reactive current injection characteristics slope. Okay, according to the German grid code, this number should be between 2 and 6. And they also wanted you to make the positive sequence slope equal to or greater than the negative sequence slope. So you put 2 here and 2 here, that's fine. So, but don't do that yet, because as I said, there are very few of those gadgets available. Now, why is the 2 lines? So given that what I just showed you, it has no negative sequence and no zero sequence, and there's only positive sequence output from this generator, no matter what. That's the state of these things now. So why would the 2 line to ground fault and the 2 line to line fault different? Well, that's because the output of this thing is based on the positive sequence voltage. So if I look at the positive sequence voltage, right now it's at 0.66. Okay, now if if I put a 2-line to ground fall here and a 2-line to ground without the ground, you're going to see two different numbers over here, right? And so that's why the outputs in those two cases, they are different. Does that make any sense? Okay, so I think that's all I have for this gadget. And also I want to bring up a whole another issue altogether. Now, you notice in this system, I don't have any loads. There are a couple of them here, but I took them out of service. And the reason I did that is that in North America, it's common for utilities to not model loads, right? I think no one disagree with that. Now, if you don't model any loads in the system, and why would you model a non-zero megawatt output for your generator? Okay. Now, if you have 1,000 buses and you're only putting in one of these, it didn't matter how much megawatts you put out. You wouldn't see any difference whatsoever. But if you have a network in an area that already has a lot of these gadgets and they're all putting out megawatts or maybe even gigawatts, well, that's going to have a profound influence on the current flows and also that affects your relay reaction. So, and this issue is only known for a very short time when this is going, because this, everybody's learning from this. Nobody have any crystal balls, and EPRI actually had done a study that I don't think they have published it yet. I saw it, and they show that in this one case, with or without the megawatt output, it actually even changes the direction of the current flow, and that's how drastic. And also in a couple of really big networks, I have found that this affects the convergence of these gadgets altogether, because you have a completely unrealistic system when you have these things putting out megawatts and there's nothing to absorb it. They all ended up at the slack bus one way or another way. I mean, we don't have a slack bus in this system, so they all ended up at the synchronous machines. So, and also let me think. Also, that person asked me, how come when I put low and no low, it didn't make that difference? It only make this couple % difference in the current. Well, that's usually the way it is. And also finally, he asked that maybe this is not one he asked, but a lot of people ask me that oftentimes when I put one of these type 4 machines in and I put a fault in here, they found that the fault current at some bus out here actually decreases when they put the generator in. And that's contrary to the experience of most people, because most of the time in the utility, someone puts a generator over here, the fault current goes up here, but it also goes up in the general vicinity of that area, right? But why would these gadgets, when you put there, the current actually fault current actually goes down, so the breaker rating actually improves rather than making it worse? There are 3 reasons for that. One is that these things, CIRs, have infinite internal impedance. So when you put one of these in, it has no effect on the Thevenin impedance of the system whatsoever. The second reason is that they put out very little current. I mean, you have, if this were a synchronous machine, you put a fault here, you can get, in the subsynchronous state, you can get 10 times the full load current coming out here. But here, it only maybe 1.5 times full load current. So you get a much smaller current. And the third thing is that on top of all that, the current that it does put out, it acts more almost like a StatCom because all the currents that come out is always 90 degrees in the VAR, in the direction of giving you VARs to support your voltage. So this is the 3 reasons why with these gadgets in the system, you actually have an easier time with the current flow. Okay, I think that's.
Sean, there's generally there are a couple of questions about what to do with the current limited model for the wind and solar, and voltage control current source for the wind and solar that been in use for a few years already. What's your recommendation to moving forward? First, are they still working?
First, let me explain what a current limited generator is. About 5 years ago, when the wind that's sold mostly by GE machines were getting really popular, and then later on the inverter were coming in. A lot of our customers wanted us to come up with something that will limit the current to something. And so what we did first at that time was to add, this is the dialog box for a synchronous machine. We added these two added boxes. One is called current limit A, and here's called current limit B. Okay. Now we have no clue how to limit the current because we don't understand at that time how any of these things work. So we say, well, we know how to limit the current, kind of. And one of the way is that knowing that the synchronous machine is represented by a voltage source behind an impedance, all we have to do is lower that internal voltage source. Okay, so I'm not going to go into it. When it's a single line of ground fault, it gets more complicated because you got negative sequence, you got 0 sequence current. It gets very complicated. But just think of the 3-phase case. We would simply lower the voltage behind the impedance. So that's what we did, okay? So that was just kind of a desperate try on our part to model these things. So in version 15 now, 5 years later, a lot of you guys are still using this. And I recommend that you stop using them altogether and go to either the CIR, which I show you, and in a few minutes I also show you the type 3 generator model. So hopefully you will stop using this as a method. Okay. Now, what about VCCS? Well, I happen to have one around here somewhere. Okay. I know that you're going to ask me about that, so I put it here. Okay. This is called voltage control current source, and I usually use the acronym of VCCS to describe it. And the VCCS let you come up with a table with 3 columns right here. The leftmost column says voltage. The middle current says current in amps. And then the third column says power factor angle in degrees. Now, in the previous version of the OneLiner, 14.8, we assumed that people were going to inject real currents, and not just a minus 90, but they would real power at 1 per unit. So in that case, it would say 1, and then this would be a non-zero current, and this would say 0 at 1 per unit. This angle would be 0, and then as the voltage goes down, so you would put some lower voltage here, and you can indicate that the current has gone up, and the power factor angle will drift slowly from 0 toward minus 90 degrees. We you can still use if you are modeling your CR, your solar or type 4 winds with this one, you don't have to change it right away. But one thing I do ask you to change is to make it not inject any real power. So this is, if you look at the new version of this user's manual that we put out with 15.4, which you have not received yet, and you look at Appendix K, and it will show you how to get rid of this real power injection. And I have done that for this VCCS. See, I tell it that at voltage 1, there's no reactive current coming out, okay? This minus 90 means that it's a reactive current. But at 0.01, which is but this could be 0.2 or 0.3 or whatever, and the current really increases drastically, usually to 1.2 to 1.6 times the photo current. And the power factor angle will still be minus 90. So the current, even though it has increased drastically, but it remains a reactive current. You say, well, what about 0.9, 0.8, 0.7? Do I have to put that into? The answer is no. This VCCS actually is quite smart. If you just put in 2 rows of numbers, it would automatically interpolate them. And if you have a number that's less than 1.01, it would assume that it's the same as the column the row that's right above it. So I took advantage of that, those features, so you can reduce your box really to really small number and inputs. So if you look at the new appendix, it shows that this is how this is done. Okay, but otherwise this is shown as this is called VCCS. Now in version 15, our recommendation is ask people to use this to model StatCom, as well as some other weird things that we haven't run across that you want to model. And it's sort of like roll your own device that you can use to model things that the output characteristics. And believe it or not, this table format was suggested to me by ABB about 5 or 6 years ago, and we used it in the working group. And now NERC has now mandated all these people that sell the solar and type 4 wind machine to provide this as a way of to the user. Okay, and so this is what I was talking about earlier. I said, but oftentimes when they provide you this information, they will say, well, this is what it looked like in 1 cycle, and this is what it looks like in 2 cycles, and so on. So you need to be careful which ones are those that you use when you enter that data into here. And any questions on that? Oh, by the way, in the 15.4 users manual, Appendix J shows you specifically how to use this to model a StatCom.
Yeah, there's a few other very specific and detailed questions about this topic, but I think for the general sake of time, maybe we'll get back to people with those questions directly by email or privately, because that's a very detailed. Okay, so.
Yeah, I didn't show anything about wind, but can I just spend a couple minutes to talk about the wind?
Of course, yes, go ahead.
Yeah, this is the what's called type 3 wind machine, otherwise known as a doubly fed induction machine. This was the earliest kind of multi-megawatt scale wind machines that were sold by GE about 5 or 6 years ago. And you look at the dialog box, so again, this is kind of small. I also asked you for the number of units and the MVA per unit. Again, now in this case, I haven't changed the, oh no, there's also an additional number here called unit rated megawatt. I'll explain to you why you need this number in a minute. And then the unit megawatt generation, this is the one that I will set to 0 so that you don't inject any real power into the system at pre-fault. And without explaining everything, let me just keep going to the unit box. And this is where you shut off the criteria for shutting off the machine. And here's the parameters of the induction machine. Okay, these are you can find this in the handbook anywhere. Now that rated kilowatt is used in conjunction with this number called slip at rated kilowatt. Well, why do I need that? If you think back in days that you model induction machines, you always need to have the torque characteristics of the thing that you're driving. So in this case, the thing you're driving is the turbine blades. And so in order to calibrate and come up with a curve of the torque, we need two numbers. And this is this came out of the APRI-funded research at Polytechnique Montreal. One of the numbers is the unit rated megawatt, which is here 75, and the other number is slip at kilowatt and at rated kilowatt. And so with these two numbers, that we can come up with a torque characteristics and make this work. So now what's different about the, let me finish by just saying the type 3 machine is different from the solar in that when you put a single line to ground fault out here, you will see both positive, negative, and zero sequence current coming out of this machine. Okay, so that's very reassuring to most people, and the current is still limited. Now, the only other thing that is unique to a Type 3 machine is the phenomenon called crowbar. And if you want the program to go in the crowbar, you cannot cause it to happen with a fault in a short circuit program, because this is strictly a transient phenomenon. But you might still want to be able to see the crowbar current, which is usually about 4 to 5 times the photo current. And because that you may be using that information to rate your substation equipment. So when you do that and then simulate a fault, in that case, the voltage high, voltage low parameters don't apply. In addition, the program will show you how much current it's going to inject so that you can do your study there. So that's all I wanted to say. Okay, so let the next presenter say something.
Okay, thank you, Sherman. Yeah, there's like I said, there are a few very specific questions on this, and I think we'll send an answer to those questions directly by email later on, so that we can have more time to cover some other thing here. Okay, and so all the questions I've seen so far entered in the in this question box are about this topic. But like I said before, this is about what's new in OneLiner 15. If you have question about anything else that you've seen in what's new in OneLiner 15, you're welcome to enter them in the question box of the webinar, right? Okay, what I can also do is so that I can share that list of thing here on the screen. You know where to find it. You go to the ASPEN website, and if you click on Home and go to What's New here, version 15, click here, and you will see that detailed question. Okay, so some of those items here, for example, if you can click on it, usually it will open a video demo of what is there. And this item, I don't know, there's no doesn't seem to be in the question. Probably that's very straightforward there. I just want to mention that this staircase characteristics for overcurrent relay now can have up to 5 level. That means you can have just up to 5 level of definite time model. And the way to do that is to enter a list of pickup and delays in the overcurrent relay dialog box. In most of the cases, you just have one pickup and 0 or 1 delay like before. But if you, for a specific application, this list can be extended to up to 5 with the comma in between the numbers. Okay, just now another remark I want to make here is that unlike in the previous versions of OneLiner, where the definite time or instantaneous pickup had to be entered in primary AMP, that was always the case for OneLiner version 1 through version 14. But now we are in the 21st century, so we decided that now it's time to, is the version 15, to enter everything for overcurrent relay in secondary AMPs. Okay, so when you open the network that you built earlier, in the previous version, OneLiner, we know that and automatically convert the primary AMPs using the CT ratio to the secondary AMPs correctly. And also when you save this file, OneLiner also, for the sake of backward compatibility, save a separate primary AMPs pickup for the sake of, if you open that file in the previous version, you will get the correct numbers. But again, yeah, so now you don't, everywhere in version 15, you can now safely think of secondary, in secondary AMP terms, okay? So, it says secondary AMPs here and also, all right. And there's a few other not too major changes here in the overcurrent relay, and you'll find that. Okay. Okay, so there's a couple of questions about this topic, so I will show that first, and I asked Sherman, who is the person who had been involved with this a lot. So in version 15, we continue to develop and enhance and add more feature to the check relay coordination using step event. This command started like 2-3 years ago in one of the 14 something version, and since then it's gotten very much more elaborate, much more comprehensive, and much better. So I think for the PRC 27, this would be an ideal tool now to get the answer. If you run that and keep that along, I think your auditor will like it a lot when they will see that, because this command will comprehensively check and give you an answer of whether your transmission line is correctly, the relay that you have to protect transmission line works as intended, which is the requirement of PRC 27. And also, this command can be run as long as you have a network model ready and also the relay model ready. You don't need to do any prior primary backup coordination specification or anything else. So we highly recommend it that if you have not using this, you might want to start using it. And there's a couple of questions about this in the question box. Let me read it aloud. When doing step event analysis, does the disk of the definite time element advance forward if it is above the pickup of the definite time element? And yes, that is exactly one of the advantage of using the step event to check the coordination, because the program will automatically, when simulating step event, take into account the prior actions of the relay. So yes, if the relay had picked up in the prior event, but it had not tripped, something else had tripped and the fault was still there, the so-called disposition or the counter, the timer counter will be kept counting at the rate that proportional to what the relay, this particular relay is seeing. And I want to ask Sherman to come make a couple of comments on what's new in the 2-terminal, 3-terminal stub line and stuff, because there was a lot of work done on that between version 14 and version 15.
All right. Yes, we have done a lot of work on these, and the stub line was fairly new at the end of the 14.8 cycle. So some of you may not have seen it. And so the stub line is simply a line that has a relay only on one of the two ends, and the other end is just open. And so this could be a line that you take it into some remote area and it has a transformer at the end going somewhere. Okay. Now, so the program now automatically simulates sublines in addition to 2-terminal and 3-terminal lines. When you say, I want to check everything within an area or within a certain number of buses back and so on. Now, one couple of things that we also added to this is it has to call tapped lines and tap transformers. Now, tap lines was in version 14.8 toward the end. And a tap line is simply a line that has no protection of its own, but rely on the main lines relays to trip when there is something that happens there. Now the program, and these tap lines that can be very complicated. In some utility that we see that the tap lines actually look like the upside down tree of a distribution system. And they are all protected by the relays on the two ends of the main line. So the program in that case would automatically identify one of the buses in the tap line that's farthest away from the point of connection to the main line. So we only test that one point, and we put 3-phase fault, single line to ground fault, and make sure that they do get clear by their relays on the two ends. Now, tap transformers, it's somewhat different. The approach is different as well. In the case of the tap transformer, tap transformer could be a transformer connected to the end of a stub line, for example. But it could also be a transformer connected to any of the tap buses in the middle of the line. And to make this work, you cannot put a relay there, because if you put a relay there, then we assume that the relay on the transformer will take care of the faults at the end, at the far end. But if there's no relay there, the program will put a 3-phase fault and a single line to ground fault at the end, and make sure that that nothing trips, because you don't want usually the fact that there's no relays on that transformer usually just an omission and not really what is there in the field. And this program simply makes sure that you put there if there's a transformer on the transformer, it will take care of itself. But if not, then it will not trip the relays on the two ends of the line. So and you can actually have this quite elaborate. You can have more than one tap coming out of any tap bus, and you can have a switch or a line before you get to the transformer. The program can handle all those cases, and so hopefully this would help you take care of most of the these small annoyances that you will have to deal with these taps.
Okay, thank you, Sherman. And I just want to add just one more quick thing is, again, this step, this check relay coordination with step event and many other check command in OneLiner is done with the assumption that you are using ASPEN OneLiner as a tool, calculation tool, but not the end user. It's not designed to be a nicely formatted report that can usually be submitted directly to the PRC or any other PRC. So most of the time you will likely want and need to post-process those output a little bit to get them at least easier to read for the auditor if they want to read them. Okay, so that's just my comment. Okay, so I guess we want to take a so we have covered the what's new in the model, and I guess the wind and solar are the most important addition in the. And we also quickly went over the relays a little bit, but there are quite a few other not too major, but quite important changes there, and I'll let you guys find that out by yourself. So there's another big important area that we spend a lot of effort and in fact time to get done for the version 15, and I can say that those development were exactly what was delaying this program for almost a year. Because it took so much effort to do, but hopefully this is one-time deal, and from now on we can build upon that for the future. And one of the things that I want to highlight is here, because nobody had asked about that, but I want it's important to point out that OneLiner up to version 14, up and through the version 14, in order to change any data field, you have to open the dialog box and enter it. I think that was a efficient way to do it for one item, but in many applications you want to have a more or less easy mass update of something, and that is now in version 15. If you open the data browser, you will see that there's a edit mode button, and once you click on it, you will be in edit mode, just like this picture is showing. So in the edit mode, you will be able to enter directly the numbers in this grid. I must say that not all of the field is editable, and if they are not, you click on it, nothing will happen. But if you click on it and it change into an editing box, and that's something that you can edit directly. You can also copy from Excel and paste this entire column if you want. Okay, so that will make it much easier for a mass update of something. Like in this case, if you have the X and Y coordinate from the GIS system for the bus, for example, you can put in Excel somehow, make sure that they are matching, they are in the same order, and just paste them down here. And then you can later make use of those numbers. And you can do that for impedance, line impedance, you can do that for the generator impedance, and so on. The one thing that still you cannot do at this point is to insert a new row. Okay, so that means if you want to add a new line, you still need to do the GUI, graphical user interface, and so on. So once you have done all the editing here, just click on commit, and the program will check. Is designed to do its best to check if those numbers are consistent, just like when you click on the OK button in the dialog box. And if everything's fine, then those numbers will go into the your OneLiner file. And if you save it at that point, you'll get those numbers. But if it failed to commit, then you will not, nothing will be changed. You can either fix that here or cancel out. Okay, so that's the idea. So that's the data browser edit mode. Okay, so also in keeping up with the theme of making it more efficient, easier, and even possible to keep ASPEN OneLiner network model and relay up to date, and also in synchronize with other databases that you guys may have. We have basically spent um, a lot of development work to provide you with a new facility for network model management. And this is combination of quite a few things. I want to highlight some of them. So first is in order to manage your model. So by the network model management, we can think of how to manage your OneLiner network model file, OLR file. And as you know, the OLR files has your line impedance and connection transformer, and also it has relays and all those kind of things. Okay, so how you can efficiently manage that. So by management, that involves how you use it every day, how you pick the right OneLiner file, or how can you tell the OneLiner file has the model that you need or in the state that you need, and so on. So that's management, and also how you add things to it to make it get the latest relay setting, for example, and all these management features. So what we have done is the beginning. We have put together a facility or framework, and then a lot of additional application and enhancement in the and easy to use command will follow as next minor release or in the major release. And also it will make it possible, this facility, make it possible for third-party vendor and developer to make their own tool to do that kind of data management. Okay, so I want to highlight a few things that that you can want to try. First, the built-in case comparison engine. So I don't know about you, but every time I open a OneLiner file, especially when it has more than 2-3 buses, I always want to know exactly what is in there and whether it's exactly that network is in the condition that I want it to be in order to run the study that I want to run. Okay, so the best way to do that is have a reference network that you know that already the condition, and if you had a way to very easily tell what's the difference between your network and that reference, or we have another term is base, then you can tell exactly uh, what you are working with, right? So that's exactly, if you have handy comparison engine that easy to use and handy, you can run it almost with no time, then you will go a long way to be able to tell whether your network model that you plan to use for your study. By network model, again, I mean the an OneLiner file, OLR file, is exactly the one that you want to use or need to use. Okay, so I want to do a quick demo of this so that you can see how straightforward and easy you can get in touch, get this case comparison engine in OneLiner. Okay, and switch to my OneLiner, which is running here now. And I think it's big enough. Let me just pick it. Okay, so this is a file. And just suppose I use this as a base, but at some point in the past, or sometimes I make this change, for example, and it was saved as some other name. Okay. Okay. So let me just save it as a number within X at front. Okay. So now, if now a few days or of even a few hours later, you open this X1. And you are wondering, hey, what's this supposed to have? Is it something right? Is it something I need to use? So all I need to do is just either use the menu, say compare file, or a shortcut Control D. Okay, I will use a shortcut. And when you do Control D, it can ask you what do you want to compare it with. So this is case comparison for feature that built into OneLiner. Okay, so you are looking at the sample 09X, and you have a base that you know for sure you kept and you check already that sample 09. And where was it? Sorry. Yeah. Okay, and you click open, and it will ask, it will tell you what do you want to compare, and then and so on and so forth. What do you want to compare within a certain area and zone, and so on. And if you hit OK, just tell you, hey, this the same thing, except in column A, which is the file with X. The length of this line is 10, and on column B, which is a file, the base, the length is 0. So I know this now. It is a more or less, if I don't care about the length, this is a good file to use to do whatever I want to do. Okay, you can also save. If normally you will see this list much longer, and the change count will be much higher. So in those cases, and you can also use on those buttons to save the result to disk, and also the result can be not only a list of just the Excel CSV table showing what's changed. Basically, it's not just this table, but you can also save the result as a change file. Again, you may know that the OneLiner has been using a so-called change file since a long time, and you can use a change file as a record that OneLiner can read to update the network based on what is in there. And that's the concept here. So you can create a change file right here by click save to disk and say yes. Then the change file and the report file will be saved. And when I say yes, and the change file, now I want to point out is if you have used the change file before, you may notice that the change file used to call CHF. And the CHF still here. You can select that, but by default, we are using something else here now in the version 15. It's called ADX. ADX, the X here is stand for the XML. So we have introduced a new data class of data format in version 15 that based on the XML standard. And so XML has been around for a long time. It's very mature way to store and exchange data and standardize as well. Some of the major standard in the power system are in XML, I think, and also and even outside the power system. So we are now in sync with everybody else in the 21st century. But if you have been standardized and the process was based on the CHF, you can still try that. And what's the difference also between the ADX and CHF is if you go into the detail, you will see that in order to update something through CHF, you will have to update the entire object. That means if you update a line length, you also have to know and update the impedance and everything that goes with the line. With this ADX, which is XML, you don't need to that. You need to update the line length. The ADX has only the line length, and everything else will be the same. Okay, so that's an advantage. Okay, so I say save the CHF here as the ADX here, and for the ADX, you can also save memo and other to indicate what's going on. And I don't want to do it now. And now I have the ADX with the we're supposed to make this change only. Okay. So and now the report in the Excel CSV, and the report will be will looks like this. Okay. I'm open Excel, and it will basically more or less show you this table where you made the comparison between those two, and the only thing that had changed is the on this line here, and with the length and going from 10 to 0 between A and B. Okay, so now I had saved that ADX before, and on purpose. Now I'll show you, though this is a comparison. Okay, so this comparison is good for just to tell manually, for you to tell whether you have a good network model to to work. But the ADX that I just saved have much wider application. And one of those is to store what your network have to go through to go from the as built state to a future state. For example, you have a new line coming in and so on. You can build a new model for that line and put it in your OLR file. So you have a new OneLiner file. But if you compare that to the base OLR file, which is as built state, and save an ADX, which is a change file for that, you now will have a way to apply that project anytime you want to your as built case. Even if the as built case has evolved a little bit, that's fine. And you still have that addition of the line and so on and so forth. So ADX is a very powerful tool for the so-called case builder. You build one-liner case out before you run the study. And that's exactly what we meant, because we had renamed. Let me open that the old file before. Remember, this file has 0 line length. As for our demo example, let's say that all the project that you want to do is just update that 10-mile number, okay? And I already have that recorded in IDX, okay? Now, so there's a command just for that. So this command in OneLiner used to call read change file, okay? But now we had renamed it and make it a little bit more fancy. So you will read the change file, which is the ADX accept, but you can also have a bunch of other ADX, you just add to it. So if you say want to reorganize your project timeline, or so some will come in when some will not come in and so on, you just keep adding. So you have one ADX for one project, you can just keep add them, rearrange them, and then you can have more than one in this table. The read change file used to take only one file at a time, okay? So now, so that's the idea. So this case builder is built based on the ADX system. So we plan to make this case builder much more fancy and more. We already have the ADX out and in use. Okay, so in this demo, I just want to go quickly and say this is just the only project, and that's the only one I want to apply. And I say apply it, and get a kind of easy to follow what is going to be changed in my as build case. And in this case, if I am reading on this thing carefully, I will see that the only thing that is going to be changed is that this length is going back from 0 to 10 or 0. So I just I can also make a change and make use of all of these thing checkbox here to decide which one I want to apply and which one I don't, and so on. So if I click OK and have that chain made. Oh, okay. So I guess let's see. And I guess I have to do this. What's going on? Now you see OneLiner. Let's see. Version 15.3, we officially found another bug, okay? Anyway, so I hope you catch the idea, okay? So I cancel out of this, my demo for actually this application somehow gone into this bug. It didn't like me applying something about this, but sorry about that. But anyway, so that's about the read change file. Okay, so it's always, again, when you apply the change file for project and everything, you always get a detailed log of what has been changed or not changed and so on. Okay, so that's what I want to mention. So that's the ADX and the feature of to update the data directly. Now, there are also several other fundamental new thing in the data format that can be that we build into this is I want to show that all the new objects in the OneLiner model now comes with a unique number, and it's called global unique identifier. And if you are involved with applying and mixing and copy data from one system to another, you will find that having those unique identifier for everything will help to match things between different systems very efficiently. And especially having this global unique identifier now makes OneLiner 15 file officially compatible to the CIM standard, called Common Information Model Standard, which a lot of ISO in the south, ISO in the south are using for exchanging data between TO and the ISO. I think I know ERCOT is using one, and I think AEP is also moving to what direction. So with version 15, I think you can more or less incorporate ASPEN data to that. It's not automatic, but without those GUI identifier, you wouldn't be able to do that. But so with the first release of version 15, now it is possible, and then we will continue to build upon that. And also, I think up here there's another thing. Okay, so this one I want to show also related to the area where you want to manage your data model. As you know, you always need to store additional things to OneLiner. Okay, and many of those things may or may not have direct application in what OneLiner is doing, which is for calculation and relay coordination. But nevertheless, those data fields that you need to store there are important for one application or another, or something in your work process or the workflow. So we have introduced in this version 15 ability for you to add more or less any number of additional fields to the core data set that OneLiner support. Okay, so the main dialog box in this picture, like transmission line data, what ASPEN has introduced, and all of them are needed for OneLiner calculation or operation in some way. But there's a button near on the right near here. When you click on it, it's called supplemental object properties, where you will have ability to add more rows to it to store things that you need. And the way to do this is very straightforward. You will go to File Preferences and go to the tab called User Defined Table field. And for each object, for example, in this case, for the line object, I've added a field called owner, and the label is owner. So the label is what you will see here when it show up. Now this field name is something has to be unique so that the program can tell one from the other. And so once you add these preferences, actually it's a line owner for it. Each time you click on this button, 3-dot button in the line dialog box to go to this field here, you will see the owner field, and then you can enter something. And this owner field will show up also in the data browser and in the export and in the DXT, the ADX file and all this. So data exchange will be much easier to do with if you have this thing matching what the external codes, or you can also do store things that you need for other report here as well. Okay, so this user defined data field. Okay, so that is the second part of the facility for data management. Okay, and the third and last part that I want to mention is a new, also XML-based data file format. I think it's compatible with ADX, but not for the change. It is for the entire network. And also ability to use those kind of format in a so-called compare and merge file. Okay, so this I will also want to introduce that those will be a basis for the application of OneLiner version 15 as a client for the ASPEN enterprise module. Okay, so I will probably want to go very quickly and explain that enterprise module with a very quick demo here. For example, if I again have a OneLiner started, and OneLiner version 15 has a built-in client for the enterprise module. What is good is for, and again, I must say that the demo or the so-called working model of the enterprise model has been built into version 15. You guys should be able to do exactly what I'm doing now. If you have version 15 on your computer. So the workflow for the OneLiner with the enterprise module will be like this. You will start out with going to the dashboards of the enterprise module. It will log you into a central location where you have all the ASPEN cases that you have built and maintained. Okay, each case will be a specific design or network level, a voltage level, or detail level. And then you will find the one that you want the most best applicable to your study, and you just save to your file. So after I save it to my desktop, this become a OneLiner file. So this is a storage, central storage in your company. Everybody will share the same case in there. But when you save it out, you are getting it to your desktop, and now you are okay to just open it. So now you are working with just your own copy. Okay, so if your work is to say update this line to make sure that everything is correct, so you update it and you save it as a new version. Then, and if this chain is important, has to go back and share with everybody, you will now just go back and say commit it to the same database, and that will get into what that everybody is sharing now. So every time you send everything back to the centralized database, you will have to comment it. I am going, and you can also check what have you changed. Okay, so then you just push it to the new location, and then if someone else is using that same database, they can use the so-called get latest. So okay, if I have if this were another person who used the original file without an update, they can go and say just get the latest, and this will go to show that he will get the latest of the impedance that was made. And this system also has the elaborate feature to see if the two people are making the same change. It will detect that, and it will not let you commit until you resolve that, and so on. So this is enterprise model is based on the automatic file merge command that we build into OneLiner 15. Okay, so again, if you want to play with this demo of the enterprise version, you just install the 15.3 and go to this menu here and play with the dashboard, open it and check it out. And when you open the dashboard, it will open a sample demo network that we sent out with OneLiner. Okay. And we'll have more detailed video and stuff later on this subject. Okay. And we have 2 more minutes, and I want to highlight also yet another feature in version 15, which we let me find it. that involve all of this. Okay, so we started it in version 14 already as an experimental build, but now it's an official. OneLiner now comes with a application program interface module, OLX API, that can be used to automatically run ASPEN application from another program. And that another program can be OneLiner itself, in which case it will call it will be called PowerScript, which is you just run from within OneLiner. You can get to that module and you can make your own application. You could also write program from Python. And why I'm hearing echo? Okay. And then you can write program from Python and other programming languages. In fact, OneLiner version 15 has been shipped with a elaborate Python application library that will take a little bit of setup, which is you will need to have Python on your computer to see that. And once you have that set up, you can see a bunch of Python application which you can run directly from within OneLiner as well. Okay, so I guess that's the very quickly to the main area that we have made advances in version 15. Like I said before, I encourage you to let's see, join us in the OneLiner training course in September. That will be on September 27th to October 3rd. The sign up can be here. Is on this line. And again, the PDF of this PowerPoint is an attachment to your webinar screen, so you can download it. This PDF and also the what's new document. And what our plan is, we have been making the recording of this session, and we will send you a link to view it when the recording is available. So I guess our time is up, and I thank you for attending ASPEN webinar, and I hope to see you in the class or online at some point. And hopefully next year we'll be in person meeting somewhere. Okay, have a good day and thank you. And we have the list of questions here. Many of them are quite details, and we'll make a list of them and send you the answer by email. And if for some reason we fail to reach out to you in a day or two, do write to us, and the email is support@aspening.com. Okay, thank you very much and have a good day. No, stop. Stop it.